Programming Throwdown, episode 145, Unsupervised Machine Learning. Take it away, Patrick.
Welcome to another, as we've termed it, duo episode. That's just Jason and myself. No special guest this time. It's because we have a lot to say. We have it all pent up, so expect a high energy episode today.
That's right. We'll start off by talking about email.
What's more high energy? Spoiler alert. I do tell this to people in my meetings. I'm like, if you're in an afternoon meeting, I'm typically more ramped up and like, you know, kind of, you think you'd be tired by the end of the day, but I get kind of like riled up
Me
about
too.
stuff throughout the day.
Yeah, I wonder if maybe we're more common, because I feel like, isn't that more natural? You wake up, your brain still hasn't really like kicked in yet. So
maybe, I don't know. And then I just crash at the end of the day, but that's another problem for another time. So as Jason foreshadowed, we're going to talk a bit about email. So this is actually a topic Jason and I were talking about, so we decided to talk about it on air, which is, if you are not in a large organization, maybe this is a foreign thing to you, but most folks, I would say, I've never looked at it actually, but I would assume a lot of people work in big companies. And in big companies, you get a lot of email, not junk mail, not spam, although I guess you could, but at my company, they're pretty good about filtering that out. But just like emails from random teams, random automated announcements, automated meeting notices, everything just gets pushed to email. And it's important to stay organized using, either rules in your client or on the server, or just making sure you put stuff into various folders or flagging stuff. I think everyone has a different scheme. I got criticized actually by my kids because I have like over 1,000 unread messages.
Oh, see, I can't handle that.
Oh, no. Oh, you're going to criticize me too. But I have a method. Like it is, I want to say like methodical. Like I do have a method to my madness. Like it is organized for me. I can't not treat incoming email.
Actually, wait, hang on. So wait, do you have 1,000 unread because you might somehow know the last one you looked at, the subject line? So you actually read them all.
Yes.
They're just
they're
marked
all
as
read.
unread.
They're all like handled.
Okay.
So it's not that they're not looked at. It's just like sometimes, like you said, I'll move the meter forward. This is on me. This is bad habit. I would not recommend it. Like you said, I'll move the high watermark forward as like what I've kind of read through by looking at summaries. And most of them, you don't need to do anything, but I don't necessarily take the extra few milliseconds, seconds, whatever, to kind of put those in an appropriate folder or get them out of my inbox. So then every so often I have to just pile through and via searching, call all the junk that needs to get marked as read. So it's just sort of like another folder for me. Like there's the unread and read folder, and they sit in the same logical folder in my inbox. I would not recommend this approach. You should definitely be more organized than me.
So I'll tell you what I do for unread is I have the, at least on desktop, I have like the double paned Gmail where like you still see the list of emails while you can see, an email you currently have clicked on. And then I have it set up to where whenever I hit the up arrow, it marks it as read. Like as soon as it gets to an email, it marks it as read. So I could just go up on the up arrow, and and I'll end up with everything read at the end, but I won't actually look at ones that are like marketing and stuff like that. I am pretty good about taking the time to unsubscribe to as many things as possible.
Does that work like in general? I guess at corporate mail, that should work pretty well, right? Like unsubscribing from something should make it stop emailing you.
Yeah, I mean, even publicly, it's pretty good. I can only think of a handful of times where I actually had to block somebody because block some marketing, distribution because they weren't respecting it. Most of the time, it's just like a one-click unsubscribe. But I think the most important thing you can do is to have folders. Folders are a total lifesaver. I'm not too sure what's the difference between the server side rules and the client side rules. That's one thing I wasn't ever totally sure about.
So I think in some cases, so like you mentioned Gmail, I think it's a bit different because the most common ways of accessing Gmail are either web apps or progressive web apps. Like they're on your phone, but they're still a web app. And so they're like the state of the client. But if you're using like, what I guess that's POP or IMAP or whatever, you could have multiple different clients. And so if the clients are filtering their kind of notifying the server and moving rules. And you could have two clients with two different sets of rules. So if you accessed your emails from two different places and the clients weren't synced, you could end up with sort of like not good stuff. I think in Gmail, as an example, when you write a rule, it's just always a server side rule, right? Like it always in the background when the mail comes in, not when you fetch the mail, the server side stuff gets executed.
Oh, that makes sense. So like you have a client side rule, but your desktop's like not on, and so now like none of those rules are taking effect. So you're looking at email on your phone and it's unfiltered.
Yep, something like that. Yeah, I think most places have moved to server side. Although I will say, I feel we at my company don't use Gmail, and in fact, I actually don't like Gmail. I preferred they killed it. This is a rant. Another time, Inbox. I jived with the Inbox way of doing it. And I was very organized when Inbox was a thing.
Inbox is
And then
nice.
they killed it, and now it's Gmail, and now I'm unorganized again. So I blame bad tools. And I know there are other ones out there. People will send us links. I know there are lots of other people and folks doing things that are clever. I don't know.
You know, I don't know if at some point I stopped getting ads. There was a period of time where I was getting Gmail ads. So like you'd go to look at your email and then the first email would actually be fake. It wouldn't be a real email. That was super, super annoying. They got rid of that maybe about a year ago or so. And so that made Gmail kind of like there's
Great
not
again?
that many that many downsides to Gmail. I did like Inbox. What was so magical about Inbox? 'Cause I also remember loving Inbox, being really sad when they shut it down. But now it's been so long, I don't remember what was good about it.
They've morphed Gmail over time to copy some of the UI things, but I think it was just like the way of handling the UI and like what was shown in the ordering of like how you went through messages and stuff was just different. I think the complexity on their side was around like needing to support both the old way and the new way. And so,
Well, one of the things I think they added was the swiping, right? So like in Inbox and then later in Gmail, you could swipe right to archive, swipe left to delete, or I don't know, maybe I have it backwards, but basically you swipe and it goes away.
you just know it's just one of those things you could just do.
Yeah.
All right. Well, we get
Um,
on to our news of the show.
yeah, my news of the show is simplifying lines with the Douglas-Peucker. Did I get that right? Peucker algorithm. Anyways,
I know what this is, but I don't know how it's said.
I have no idea how to pronounce that person's name. I'm sure I butchered that person's last name. Anyways, this thing is really cool, and I found a particularly cool article where they kind of walk you graphically through how to do this. But I was always really interested in the game Worms. Do you ever play this game?
Yes.
Yeah, so Worms was this, pixel-based physics thing where, there's also Scorched Earth that was kind of similar, but much more simplistic.
Tanks.
Yeah, in Scorched Earth, like things couldn't float, like the ground always settled, and so it was somewhat of an easier problem. But in Worms, yeah, there would be these floating islands, and you could walk on them, and you could bounce grenades off of them and stuff. But anytime there's any kind of explosion or anything, it would chip away at these islands, and it would start to take away some of the pixels. And so I was always fascinated with this, like how do you bounce a grenade off of this pixel, like this 2D array of this binary array of pixels. And so that kind of led me to this algorithm, which is really cool. So basically, you could imagine kind of tracing the outline of one of these islands, and then just anytime there's an explosion or something, retracing that part of it. And maybe an explosion caused an island to split into multiple islands, and that's fine. You could detect that. But then you have this problem of, okay, now I've traced this island, and I have this the outline, right, the shell of this island. How do I put that into a physics engine, right? And even if you were to put every point in a physics engine, the angles would be all really jagged and stuff, right? And so looking at some game development sites kind of took me to this, which basically this algorithm is this really fast way of saying, okay, I have this, it could be a line, it could be a polygon, it could really be anything, but I have this, line that's made up of a ton of points, and I want to keep sort of the structure, the essence of that line, but get rid of, a ton of the points. So it's a simple unsupervised way to do that, which I thought was really cool. And the gist of it is you essentially like go from the start to the finish. I guess this wouldn't work if it's a loop, so there has to be other ways to do that. I think it still works, but you have to adapt a little bit. But you go from the start to the finish, and you kind of draw a fat line. Like imagine like a rectangle that's oriented, right? Like a fat line from the start to the finish, and then you see like, okay, are all the points just in that line, in that rectangle, in that zone? If they are, you could just delete all of them, and now you have just a start point, a finish point, and a straight line. But if there are some points that fall outside of that zone, then that means, if you were to delete that point, you'd kind of be changing like the essence of this. So like maybe it kind of like is more of like a parabola or something, right? So if you find a point that's outside of the zone, then you kind of do this subdivide type thing, or it's like a divide and conquer approach where you say, okay, let's go to that point and create a rectangle from the start to that point, and then a second rectangle from that point to the end. And now with these two rectangles, did I cover everything? And so you kind of keep going in this way. And yeah, it also looks like really mesmerizing. So it's if you ever wanted to make your own worms game, this is how you would do it.
Yeah, I think there's a few ways of doing this like line simplification. This one uses like you're kind of saying this fat line as like lateral stuff. I think there's some that use sort of circular distance as well, depending on what you want to do. But yeah, you're trying to like preserve the shape, but also simplify the number of points.
Yeah, exactly.
Cool. My news article is how to pick a starter project. Now, ironically, or I guess this takes the stance initially of telling you how to pick a starter project for someone you want to get rid of. And by illustration of all the things that you do to get rid of someone, highlighting how to not pick a starter project. Uh, and it's kind of a funny thing, but I guess nothing in here is sort of earth shattering, but reminder that starter projects really are important for onboarding new folks, like those first things that you have them do and making sure that it works well. It also gets in a bit to how to choosing mentors and that kind of stuff. And I just wanted to highlight because I think this is a really poorly thought through thing, like how to onboard new people to teams. And some companies will have like a company-wide onboarding process, but I think like still the importance of within a team making sure new folks get up to speed and how that's like a joint thing across the manager, but also the members on the team. And so here it's highlighting things like pick a gigantic project that has vague requirements and goes cross team and cross discipline and is tracked at a very high frequency by upper management. These are all ways to inspire someone to quit on the spot and to not get brought up to speed. I think like oftentimes even under poor circumstances, people do integrate into the team eventually. But I think like often those formative first few months are critical to kind of having a really positive experience and making sure that the team knows that they should be taking time away from their other tasks to onboard a new person. And I think like whenever you change jobs, it's always difficult in the beginning. And I can look at these comments and think back to some of the times I've switched teams or changed companies and had starter projects which more or less sort of, I guess, were intending to push me away. Maybe I was too dumb to realize that I should have changed jobs. No, just kidding. You
Your
know,
starter project is to delete all the code that your boss wrote.
I, I did have a starter project that was you're new to the team. The team's been divisive about coding style. So why don't you come in and start enforcing coding guidelines?
Oh no, that's you got to be kidding. Is that
Nope.
real?
Nope. Yep. That's absolutely true. Anyways, on to the, but it is important. And I think as well, if you say, well, okay, I'm not a manager or whatever, I'm not assigning starter projects. I think it's important to know that this is a thing and a thing that people don't always do well. And so if you're new to a team and you're not getting good work, like be communicative to your boss that like, or your coworkers like, hey, this seems like kind of vague. Like I'm happy to work on it, but is there other stuff that I could, be doing as well? Like be proactive in being an advocate for yourself and trying to, assuming that they're not doing it on purpose, like trying to get work that you think is cleaner. I would say like one of the more common unintentional mistakes is giving someone something you didn't realize that was a lot harder than it actually seemed. And so you give someone a project, you think it's really easy, and then they really, really struggle. This has happened to me before. And then it turns out once you sort of start reviewing what you're doing, people are like, oh, I did not realize this was that complicated. I just thought you were kind of slow. And it's like, well, people really should be assigning work that almost they would just sit down and do in an afternoon. Like it really should be too easy. Better for them to finish too fast than to get bogged down.
Yeah, the other mistake I see a lot is where if there's a junior engineer, someone will a manager might say, "Oh, I really wish I had time to, work on project X, which is some new project that the team, no one on the team has time to do project X, but if we did it, it's like this big win." And then somebody joins the company, and you say, "Oh, this person has, 100% free time. They just joined. So we're going to put them on Project X." And it ends up being this really risky thing. And from your perspective, you feel like, as a manager, you might feel like, well,
I'm
this
giving them
person's,
opportunity.
yeah, this person has a chance to hit a home run, and there's no downside because they just joined, and they can pivot, and they're not going to get evaluated right away or anything. This is actually a terrible idea, right? So the reality is people are under kind of the most pressure to perform in the beginning. And so, this advice here in the article about, put somebody on the main bread and butter project. Like, I see people mess that up so many times. But yeah, as Patrick said, you want, especially for junior folks, but even for senior folks, you want them to be exposed to the core essence of the company, even if your long-term plan is for them to try and invent something new. Cool. So my article is Tic-Tac-Toe in a single call to printf. These code golf things, I love these things. I've never tried it. I don't think I would enjoy actually building this. It's more of like an art installation than a coding exercise. But it is so freaking cool. So, as you might imagine, there's a ton of pound defines to make this a reality. There's a certain way in printf you can actually capture input.
I did not know that.
I didn't know it either. Yeah, it's I'm trying to find it here now. I mean, there's a whole document here on how they actually did it. Anyways, there's a way you can capture input with printf, and they're hijacking that. And so basically, this prints a tic-tac-toe board, lets you type in input and play games against yourself. The entire thing is done in one printf call. There is a while loop, while printf. I guess that's because every time you enter a key or something, right? But really freaking cool. And they actually took the time to make it like actually visually artistic. So the entire program is spaced in a way where there's a ASCII art %n in the program. So it's they're actually I take it back. There is a scanf.
Yeah, I see that in the argument to printf. There's a scanf.
Oh, okay. So actually,
no, but that's still crazy. I didn't know you could. It does not seem like a good idea.
Oh, the scanf is inside the printf.
Yes.
Oh my gosh, my mind was just blown.
That's not that bad. It's just in the argument string. So like comma, scanf, open print. So it's just a function call that's taking place, and then the result going in as an argument. Okay. This is not as like
sense.
devious, as cynical, okay. This is so crazy, but I got it now.
Okay, got it. Yeah, I got it too. Yeah, so it's a call to printf, but that printf has as an argument a call to scanf. So there's two functions, but the whole thing is freaking cool. I love seeing stuff like this. So definitely check it out. It will give you a chuckle, and you can read through how it's implemented, which is very clever.
It will give you a chuckle if you're either very against C or very deep in admiration for your C programming language. I think that those two folks may like it. Everyone else. Jason's description may be sufficient for you to realize you could save yourself the click.
Well, you could copy paste this into your terminal and GCC it, and then play tic-tac-toe. It'd be a fun exercise. They even have instructions on how to do that if you're
there were only a web browser where you could just like type a website and play web games that don't involve incredibly obfuscated C code. Okay,
Oh man.
this is pretty cool. I would say the name almost is also a good competitor for obfuscated. So they did a good job naming it to seem really sinister. It also claims printf is Turing complete, which doesn't surprise me, but sounds horrible.
Yeah. Oh my gosh, that's wild.
That's probably like a complexity measure of your language, which is like how many features of your language are themselves Turing complete.
Oh, interesting. Yeah, I wonder, I wonder what, so there's been historically been languages where I've had a hard time working with them. And I feel like that's pretty common. So one of them is Scala, another one is Haskell. Those are two languages where I don't have strong opinions. I mean, I actually enjoyed Scala, but I found that the programs that when you started to scale up the team size, Scala and Haskell both became really difficult for me, at least, to understand. And so, yeah, I wonder if there's somehow a connection. Like, I wonder if you could somehow take all of this anecdotal evidence and regress it to say, okay, yeah, somehow some complexity metric of the language causes it to balloon in this way.
Interesting. So why is Python so bad as a programming language then?
What is the
No, I'm just
zeitgeist on Python?
Oh no. We're gonna get debunked. We gotta keep making progress.
Okay.
I don't know. I don't know. We also throw JavaScript in here too. Um,
Oh my gosh.
okay, mine is completely unrelated. It's not an obfuscated C code, although it probably does have C code on it, and that is the Artemis 1 project. By the time you listen to this, hopefully it's successfully launched. At the time of recording, they've sort of attempted the first launch, which got scrubbed. But I want to say this had been a big deal for a long time for the United States government trying to send a rocket effectively back to the moon. This first one unmanned, eventually, a manned moon base. Contrary to the last time that the United States to the moon, this one's actually being done much more internationally. Some of the sections of the rocket are actually done by the European Space Agency in collaboration with NASA. So I feel like this is a bit different in that way, leaving all the politics aside of the last one. But I want to say, I feel like this came a bit out of the blue. Like, it is a big deal, I think. And I think that it had been going on for so long, so much of a run. People kind of forgot about it. And then it was sort of like, oh, it's on the launch pad, getting ready to go. And so that's pretty exciting.
So yeah, I mean, again, politics aside, but I thought that back in like 2010 or something, they totally defunded NASA. So I was like really surprised to see this. So I really don't know how like what really transpired there.
Yeah, I don't know about defunded NASA, but there's been a history of telling various government agencies in the United States like what to do, but then not giving the funding. So it's like a two-step process. First, you give them like a new mandate, and then you're supposed to like go and in the budget, sort of like budget for that new mandate. And so there can be like, hey, you need to go do X. And then we go to make the budget and we don't give you money to do X. So are we really telling you to do X or not? It's a bit ambiguous. And so I think that's true of NASA, but true of other government agencies, but I'm not sure on the particulars. But no, it hadn't been defunded. It had been sort of, in some ways, people would say uncancelable because it was involving so many states, so many companies, so much, international cooperation. There's just all this stuff, and it just sometimes, estimation for timelines. We are not that software engineers the only one who get them wrong, but other companies get them wrong too. But no, I mean, leaving that aside, I think it's exciting. Like, people quibble over the expense of it, but I think that giving that sort of optimism and hope of going to space and putting people onto the moon and the immense amount of technological research that falls out as part of this, I, I, I think it's an exciting thing. I won't justify that it's worth the cost or not. I don't know. I kind of, it's hard to say,
Yeah, it's
but I
really
will
hard
say
to
that
say.
it's exciting. And like, for, having myself children who are elementary age, their teacher turned it on, they get excited about things about science. I think, like, from that stuff, it's really hard to measure just how big of an impact these kinds of things have.
Yeah, I was talking to somebody about something related to this. I was talking about how if you look at like the Sistine Chapel and the the pyramids, like how we did these things that were kind of like really powerful and then also like wholly unimportant at the same time, like the pyramids. So the pyramids are extremely cool as a tourist attraction, and I'm sure Giza like generates a lot of tourist revenue from it. But like at the time, like it was just maybe like a thing to do, or it was like a religious endeavor. I don't actually know the history of the pyramids, but I feel like the humanity is full of these sort of endeavors where it's like not totally clear what to do, but you do feel like this is sort of like a milestone in humanity, whether it like turns it to something economical or not, right?
It's always hard, right? I think these things are complicated, but from a celebration of what humanity can do for along this like technology, pushing the envelope, doing these new things, I think it's incredible. Also, there's been a theme of various space and rocket related things throughout the history of the podcast. But I mean, I think I said it, I think even for our predictions for this year, which will probably end up needing to slide out or whatever, but the amount of new rocket hardware coming online and people doing things. We haven't had as many of these duo episodes, but there's a number of other sort of interesting rockets coming to fruition. It's really cool that soon our ability to access orbit and access things like the moon are going to be just so different than they were before. And I'm really excited to see what we're not anticipating about such a transformation.
What do you think about the space slingshot? Have you
Oh,
seen
spin, is
this?
it spin launch? I think that's the name, right?
Oh yeah, I don't know.
It's
I'll
not
look
a
it
sensor.
up.
You're talking about the one that spins in the centrifuge that's in a vacuum and then launches. I mean, I think it's one of those people have done stuff similar before in research in giant, artillery guns basically that would shoot rockets out. The rocket equation, which is this is not my area of expertise, but basically the fact that you need a huge amount of rocket fuel to lift your rocket, but you add rocket fuel, and rocket fuel is heavy, so therefore you need more rocket fuel to lift the rocket fuel to lift your rocket, and you end up with this sort of like cascade of stuff. And the Earth is in a pretty heavy gravity well, right? Like it's the atmosphere is dense, the Earth is massive, so it's pretty hard to get to orbit. And so if you can get just a little percentage of Earth, its diameter away or Earth's radius up, and sort of lessen the effects of gravity, lessen the effects of the atmosphere, and just sort of get through those really quick by energy held in your launch device, not in your rocket, you simplify a ton of things. Of course, doing that has its own caveats with acceleration and stuff. But I actually Spin Launch seems to know what they're doing. That is not necessarily always enough, but they built something at a scale people didn't really think was possible. I feel there's a lot of armchair quarterbacking, so I'm hopeful that it'll work, because the idea is you have this giant circle that stands up on its side. It gets almost all the way to a vacuum, and just very, very little air left in it. And then they rotate this huge arm in the middle with a rocket on one end, basically. And then at the right time, they unleash the rocket, and it's shoots out like a sling, shoots up into the atmosphere, and it gets through all that hard, dense part of the air, gets to a pretty high altitude, and then lights its rockets. And so it can be a much cheaper, smaller, more compact, and you can launch a lot of times because you just load a new one up and you do the same thing again. And so, I mean, if it works for small satellites, it would be a huge unlock.
Yeah, I mean, it looks really freaking cool. I mean, Patrick did an amazing job describing it, but you have to watch the video. It's just really, really cool to watch.
Fingers crossed. I hope it works. And also, good luck, Artemis. And if you already know what happens in the future, well,
Yeah. Wait, actually, so we should predict. Do we predict Artemis will launch in the next month?
okay. Well, we're recording at the very, very end of August. So you're saying by the end of September.
Yeah, so I think this show will go out in October, but anyways, so let's say September. Will the rocket launch in September?
Well, the rocket will have had launched in September.
Yeah, that's right. Nice job.
I'm going to say yes, just because I want it to be true.
All right. Yeah, I feel like it will too. I mean, they're so close, right? I mean, I think it was just some kind of liquid leak or something. I mean, they could easily fix that.
Flex Seal. Just slap that on there and it's good to go.
Oh
Now you
man.
know why Jason and I are not rocket scientists. All right.
Yeah, exactly. Oh my gosh, it's amazing. Flex Seal. I bought Flex Seal tape the other day. It actually is pretty awesome. I used it to fix a hole in our pool. Like, the pool has your pool has that thing which like goes on the bottom of the pool and like cleans the bottom,
Okay.
like a,
Yeah, like a
I don't know what
vacuum.
you'd call it. Yeah, basically a pool vacuum type. Well, pool vacuum means something else. That's like a thing that you manually do. But anyways, so I used Flex Seal to fix a hole in that. It actually worked pretty good. I was impressed. I think there was this one I found online that I also ended up using for some other project that actually it gets hot when you stretch it, and it like
Oh,
the tape like chemically bonds to itself or whatever. It's like wild. I mean, they have amazing crazy tapes now on Amazon.
we could talk about the tape that's like electrically conductive, sort of through the thin part, but not across the tape. So along the long part, it's not conductive, but like so if you can pass through the tape, but not along the tape electricity.
Whoa, that's wild.
Okay. Anyways,
All
all right.
right. Oh,
It's time
actually,
for.
one more shameless plug. So there's a gentleman that I know who started a company called BitRip, and BitRip is basically, I mean, I'm probably going to totally butcher this, but imagine just like a roll of tape with QR codes. And so the idea is if
Oh,
you're out in the field, like you're an electrician, like a public utilities worker or something, you could just like slap this on anything, and then you scan the QR code and put some data into some app, and then someone behind you can like scan the same tape like a year later.
I see this. So it's like every rip is like a unique code. Is it? So is it like a non-repeating pattern? Like a what do they call that? Oh man.
I
Ah.
don't know the details. I always thought it was just like tape with QR codes on it, but I haven't actually seen the product.
Oh, okay. Well,
Let me see. BitRip.
yeah, it looks a little bit like QR codes, but they're not exactly QR codes.
Oh yeah, you're right. It's almost like a barcode or something, but it's somehow there's a unique fingerprint.
Now I'm curious what you brought this up, man. Now we got to know what the secret is.
We need to get the BitRip guy on the show. 600 GPS tracking tags, embed photos, documents, audio. Oh yeah, it's definitely not a QR code. It's some kind
It looks like
of.
a Penrose tiling. If I just had to take a naive guess, I think it's a Penrose tiling, which is like a non-repeating infinite series.
I think you're right. Yep, yep.
But okay, oh, we probably messed up his pattern. We probably shouldn't be here like reverse engineering tape on the.
Yeah. So how many of you think that in the month of September we'll get sued by the BitRip guy?
All right, it's time for booking the show.
My book of the show is The Meditations by Marcus Aurelius. So I remember first hearing about Stoicism a long, long time ago and thinking to myself, oh, that's pretty much me. I live like a really relatively simple life, always trying to simplify things. And it kind of really resonated with me. And so years and years later, I decided to read this book. Marcus Aurelius is wouldn't say he's the founder of Stoicism, but he's the person who really kind of popularized it. And I guess it was a bit of what's the word? Like I think I'd overhyped it too much in my mind. It's kind of like, actually, Patrick, you brought this up before the show, how it's like another one of these books is The Art of War by Sun Tzu, where like everyone talks about these books all the time, and you think, oh, this is like going to be something that's going to totally blow my mind. And what I actually found was that so many people have already talked about this book that like I already kind of knew what was going to happen, and so it's almost like kind of watching the movie of Jurassic Park after you've read the book, or maybe Harry Potter or whatever, any of these. So it's kind of like, it was a little bit underwhelming because I'd already kind of known the material. But I felt like it was still a good book about halfway through it. If you don't know what Stoicism is, or if this sounds interesting, if you're interested in how to lead a simple life, like what that means sort of like metaphysically and everything, check it out. It's a good book. It's also, obviously really dated. I think Marcus Aurelius was like a Greek emperor, I think, or Roman emperor. I think
Yeah, it's
Roman
Caesar,
emperor.
right? A Roman emperor.
Roman emperor. There you go. So yeah. So I think it's going to be a very dated book, but it's a little difficult to read. But I think it's nice, and it could be sort of something that you do, while you're in the car and just kind of have it in the background. And there's probably a lot more contemporary books on Stoicism and the other kind of philosophies I highly recommend.
I think understanding some of those philosophies and approaches, even if you're not saying, hey, I'm actively seeking to model my life or to do this as like a key tenet, I think still are useful for helping see how other people think, to just like have new ideas, and to kind of like question if there's some nugget of value there for some part of your life, rather than necessarily reading a self-help book where you're saying, I'm going to adopt this as like everything about who I am and make it my core identity. I feel sometimes there's, I don't want to say like a pressure, but in my head, at least, like a thought, like, oh, if I read this, I'm kind of wanting to adopt it as like, and I don't think that's accurate. I think, like Jason's pointing out, you can read it and still learn a lot from it.
Yeah, I think, I was really fascinated when, we were working on YouTube. I was really fascinated at like what made things go viral. Like what actually makes things go viral. And one thing that I learned in that process is that a lot of things that you think are organic are actually not organic, right? So there's actually a lot of viral videos where you look at that and say, "Oh man, perfect timing," but it's actually highly, highly scripted. So it's very hard to tell what's real, what's fake. But either way, I think that what I noticed was a lot of viral content on really anything, any type of media, it sort of taps into this kind of like latent, I don't know how you describe it, just like latent, like shared, common sort of culture, like the sort of like hive mind of humanity, or maybe hive mind of, if you want to be more local, like hive mind to your country or your region or whatever. It's like it like doesn't directly say like, hey, we're going to talk about stoicism today, but it just like it sort of taps into a lot of that sort of latent energy. Like Harry Potter is the example that keeps coming up in my mind. How if you actually look, almost all of those stories, like the at one point they fight a snake, and that snake, like Harry Potter fighting the snake, is like you can see the parallel to this other like ancient story that people read for like hundreds and hundreds of years. And so it's like you have this evolutionary like footprint, and really popular content sort of like taps into, like piggybacks on that footprint. And so, yeah, reading like a lot of these canonical books will give you kind of like an understanding into that, which would help you if you ever wanted to write, or produce some content, like write a book or anything like that that wants to tap into that same energy.
Well, as tradition holds, Jason gave us a very highbrow, very thoughtful book. This may be a bit late, but we've not done as many of these recently. So it was all the fad during sort of like the COVID at home stuff to kind of bake sourdough. I see that. I see that meme.
I remember
But
that.
mine is a book about bread baking: Flour, Water, Salt, Yeast, by a gentleman named Ken Forkish. And there are a lot of books about bread making and artisan bread. And I think this one, for whatever reason, just reading it in the stories, it really kind of like made me excited to try the recipes, to do them, to take the approach. I just thought it was a very thoughtful way of thinking about bread
That's a
baking. There we
tough
go. I
one.
can. And just using simple ingredients. I guess they call it sort of like a lean bread, which is there's no fat in it, right? Just flour, water, salt, and yeast. They of
Wait,
course have
is that
other
literal?
recipes.
Like, do they literally put fat in bread?
Yeah, so an enriched bread. So like if you, I'm like a challah bread, or you know, something like an egg roll, right? Or like a yeast, you put egg or butter or oil. Like a lot of pizza doughs have oil in them.
Wow.
Um,
Oh, okay, that makes sense. Yeah, pizza dough.
yeah,
Yeah.
and so those would be like enriched in some way with some kind of fat. And so the like and a lot of bread we eat has a little bit of that. And so kind of going back to this very basic sort of loose shaped, round bread gained popularity. I know in like on the west coast of America, the sort of like Portland and San Francisco, these places have like kind of developed a renaissance of this style bread making. But if you're interested in bread making, which most of you probably aren't, that's fine. This I would encourage you to check out this book. I really like this book. I baked a lot of the recipes in here and had a good time. I don't get super into it. Probably should do it more, but it does take quite a while. It's an endeavor, but it feels good at the end to really eat it. And there is something hugely different about eating a loaf of bread, smelling it, cooling it, eating it, that you made, versus going to the store and buying one. And so I think it's something that people should try at least once.
Yeah, this is super cool. So I was looking up the author to see if Ken Forkish is a real name or not. It just seems like too good to be true to write a book about cooking and your name has fork in it. But so far, everything I see, look up say that it's not a pseudonym. There's actually a real guy named Ken
I did.
Forkish.
I didn't even think about that until you said it. Yeah, I think he runs a restaurant in I think Portland.
That's right. Yeah, you got it. He runs a bakery in Portland. And he actually, before opening that bakery in 2001, he worked in Silicon Valley as a tech worker for
Oh wait, I didn't
20
really.
years.
Oh, maybe this is why it resonated. I didn't know this.
Yeah. So that's wild. So 20, so that means he went to Silicon Valley in 1981. That was probably when it was literally silicon, like making chips and everything. Then yes, worked there 20 years, opened a bakery. Good for him. Very cool. All right, so time for tool of the show. My tool of the show is this app called Pythagorea. I guess sticking with the Greco-Roman theme that I have going here. So Pythagorea is this game that where you basically have to solve geometric puzzles. And so that sounds like it would be really boring, like, doing math homework as a game or something. But they actually do a great job of making it really engaging. One of the things that they do really nicely is, the game is played on this 16 point grid, or maybe no, it's more than that. This 36 point grid. So there's a 6x6 grid of dots. And so, the first level is very simple. There's a dot on the left side, dot on the right side. They're like, find the dot in the middle, you tap the middle of the screen, you move on. And then, it kind of tells you, hey, you have two dots, make like an isosceles triangle. And so you can drag lines between the dots to make triangles, but you're restricted by these dots. And the dots, the fact that you can only draw a line either from dots to dots, or you can make new dots where two lines intersect. That's where it starts to get really complicated. So, for example, there was one puzzle where you kind of needed a point that was sort of in the middle of 4 points. So you needed a point where there wasn't one. And so what you have to do to solve that is you can just make a little X, right? So imagine your mind like 4 points, in a square shape, right? And if you draw the two diagonals, now you have an X, right? And so then in the middle of that X, you can actually tap that and now make a fifth point in the middle. And so you can now, like, when you get to the harder levels, now it really opens it up because you can really make a point anywhere as long as you can figure out how to get two lines to intersect at that place, right? So the hard puzzles start getting really hard where it's like, okay, I need to go to like 7/16 of the way between these 2 points. And so like what lines can I draw to like make that happen? And so it's really fun. I mean, it's one of these things that's like very hard to explain, audio through audio. But I highly recommend you check it out. The other thing is it's completely free. It's a donationware game. So I went and gave them, I think it's like $1 or whatever that they're asking for. But you can play the entire game cover to cover, totally free, no ads, nothing like that. And I found it really stimulating. Like the other thing is as soon as you get it right, it kind of dings, and you know you got it right. You're not really guessing. And so some of the levels, I would stare at it, and then I'd kind of find out, okay, here's sort of the trick. And then you get that trick, you solve the puzzle. It's very satisfying. I felt like they did a good job with the pacing. A game like this, it's very easy to make a level that's extremely difficult, and then you just can't move on, and it's really frustrating. They did a good job of ramping up the difficulty, and one of the other things they did to help with the pacing is the game is broken down into chapters, but the chapters aren't in increasing complexity; they're just different phenomena, geometric phenomena, and you can actually play all the chapters asynchronously. So if you get stuck on chapter 2, you just go to chapter 3. So I felt like that was also really clever game design. And yeah, definitely check it out. Totally free, so there's nothing to lose.
Awesome. That's really cool. So now you're going around with like a compass and ruler and making dodecagons and like showing all
Yeah,
your friends.
everything looks like a geometric problem. It's like, okay, this door won't close. Let me pull out Pythagorea.
That's awesome. Mine is, we might have even had this as a tool to show before, but that is Google Keep. I feel a lot of people may have heard of this before, but some may have not. And it's a way of doing note taking. But I think the power that I had recently realized about Google Keep is sticking with it and using it and jotting what amounts to kind of like post-it notes in the app or on the web, or sending links as like a way to doing bookmarks and putting pictures in, and just sort of gathering a lot of unorganized data and then just being able to search it, to be able to go to like dates, to be able to, you can do categorization, but even just leaving it messy and then putting stuff there over time and building it up. And then, something happened to me where I was like, oh, I think I had written this down one time, or I was cooking some dinner and I was like, oh, I think I last time debated what temperature to put this at. And like, oh, let me go see. Oh yeah, sure enough, I took a note here because it felt like something I'd want to remember. And so just putting these little like jots of a note or a picture or a recipe or a link, and being able to find those things later. Anytime where I try to figure out something that I knew and I don't or couldn't find, I always try to make sure to go put it in there the second time, because if I needed it, twice, probably going to need it again. And so building that up over time, I think there are some open source or different alternatives and other platforms that people use. So my tool is Google Keep, which Google allows you to use for free. It comes with all the traditional Google cons, I guess. But that is a pro. But then,
Wait, are there ads or no ads?
I don't think I've seen ads, but people in general have a love-hate relationship with Google these days, which I completely understand.
Fair enough.
And so don't put any private information there, I guess, that you're not willing to share with Google. But, using a tool like this, I guess, would be my shout out, which is something where you can just very low overhead, not super structured, just sort of put your information in and allow it to kind of accumulate. We talked about the importance of email organization. If you're super organized, maybe you don't need this. I already fessed up in the beginning that it's something I need to do better at. But, I think here this is a way for me to kind of not lose those little ideas.
Yeah. Do you rely on search then to retrieve the notes? Okay, so the notes aren't like hierarchical or anything.
No, I've seen stuff and always been intrigued about doing that. I feel like the hesitation for me for hierarchical or like linked notes and stuff would be really cool, except that I just know that I'm going to worry more about where in the hierarchy goes. And then therefore I'm not going to put stuff in if I don't think it'll fit in the hierarchy.
That makes sense.
So here it's like, I need to just record it.
Yep. Totally makes sense. I wonder if like maybe we could automatically generate the hierarchy.
Oh, what do you mean?
That would be pretty cool. Like maybe with some unsupervised learning.
Speaking of which, if only our episode today was about...
How did that happen?
Cluster my notes.
Clustermynotes.com. That needs to be... Oh, did I tell you it's a bit of a side topic? Then we'll jump in on supervised learning. I made a website called visual-if.com. The idea is the UI is very clunky, but it's an interactive fiction game, but it runs Dolly as you're playing the game. So, you type in like, you get past the intro screen and it's like look up, look down, move east, like one of these interactive fiction games like Zork or Adventure, right? But anytime there's a room description or anything, Dolly is running in the background and you get like some crazy, art installation of whatever that is. And it really actually makes the games really fun. If you've played interactive fiction before, if you've played a particular game before, you could play it again and just see all these really trippy pictures with it. See if it matches up with what you were envisioning when you played it the first time.
I'm not sure if I went to the right spot or not. It's either really well done to be confusing, or I'm on some other random person's website.
So it's Photopia is the game that starts when you...
Okay, yeah.
Yes, it says, would you like instructions? Yes, the UI sucks. I'll admit it. So it says, would you like instructions? You actually have to click on that and then type no or yes.
Okay.
And then it says, will you read me a story? You have to actually click again. And then now you're in the game. I need some way to maybe I should make like a little intro screen before the game. Kind of tell people what they're in for.
Nice. This is cool. I mean, these pictures are like kind of creepy. I'm not going to lie. The ones I'm getting. So.
Yeah. It's like, there's like a person skiing or something. At least that's what I see. But yeah, it was pretty fun. I might try and double down on that if I have time. So I found out people didn't really understand how to use that product. Like I just asked people, and they're like, I don't really understand what I'm supposed to be clicking on. But as you kind of work on any type of product, definitely you can show it to your friends. You could try it out yourself, but you will eventually want to show it to strangers, right? And as we talked about with Kevin in the marketing episode, right? Eventually, you're going to give your either app or website or whatever you're building to the public, and you're not going to be able to really look over their shoulder and find out what they were thinking about it. So, definitely we talked about marketing and surveys and all of that. So there's a whole human element too. But another thing you want to do is you want to kind of gain insights from data. So ideally, imagine if you're making like this app, for example, this visual IF. I didn't implement this, but you could imagine, I could track where people are moving their mouse or what they're clicking on, or if they're clicking, how long they're spending on that site. And that could, all go into some kind of report that would give me information. And then I could even go a step further and A/B test. I could try a new version of the site, see if it improves, right? The challenge is, all of this data that you're going to get is going to be highly unstructured, right? So imagine, it's going to start with these print logs that maybe you did when you were doing development. So, print, person clicked on a page, or print the page ID, or print, person moved the mouse to the bottom of the page, right? And you have to somehow turn that into something that you can look at, some type of graph that you could look at and say, oh, here's some, thing that I can do to make things better. And so that's at a high level, like one of the main things that we want to do with unsupervised learning is take, a lot of raw information. And like, the one of the biggest examples that is used repeatedly is Wikipedia. Take all of Wikipedia, and can you just learn something from reading, having a computer read all of Wikipedia? So that's basically what unsupervised machine learning is all about. And yeah, I think Patrick, you brought this show topic up to the table. I think it's a great show topic and something that I am really passionate about. So
Yeah, I mean, I think like Jason was saying, this taking your data and sort of like helping to structure it. But I think, and I made the joke about clustering earlier. I feel that sometimes Jason is a machine learning, let's say, practitioner, right? Like that's his trade. I'm not. So in general, I try not to do it, not because I don't know what it is or can't do it, but just because it comes with certain, I don't know, I'm gonna say expectations. And so when I set out to do work, it's like the engagement model I have with the data that I have in front of me and with the task at hand is a bit different than Jason might have as a machine learning practitioner. At the same time, I think this area in parts has a lot of overlap between, and I'm just making, I don't know if there's probably a better word, but sort of machine learning practitioners and sort of other folks. And so I think there are things like, for example, like clustering, where there may be features of your data, or heck, there might even already be numbers that you have along multiple dimensions, just even 2 or 3 dimensions, where if you clustered them together and looked at them, that would already be quite helpful. And you may say, well, that's not machine learning, that's not, there's no neural network, there's no, whatever. But I think that's okay. I think things where you're fitting a regression to your data and trying to say, hey, look, there's numbers here and I'm fitting a line to it so I can think about what the next number would be, or between 2 numbers, or out past the last data point I have, right? I think those are kinds of things where you are overlapping in a lot of this, and learning about those things and thinking about them in those is another tool in the toolbox. We talk about that all the time. And so I'm pretty excited to talk about some of these things because I think a lot of them have value, even to people who wouldn't call themselves machine learning practitioners, but anyone who has data, which turns out to be a lot of people, or most people have some amount of data they're trying to work with, and ways of organizing, cutting that data down, smoothing the data, thinking about the data, all those kinds of things.
yeah, right. Yeah. So I mean, imagine like you have a bunch of data around, people who visit your website, right? And so you want to set up, clusters. You want to set up kind of cohorts. For example, you might learn that there's somehow like there's a lot of identity around age. So it's like the people visiting your website are either really young or really old for whatever reason. And so maybe they're coming for two different reasons. You have to figure that part out. But clustering will kind of looking at these centroids. The centroids are the centers of the clusters that you've developed, can give you a lot of information. So for example, you might have a whole bunch of different features, and then you might do clustering, which basically says for each of the data points, and a data point would be sort of like a set of features. So maybe a data point is a person who's come to play your game, and a set of features about them, like how do you describe this person, right? And so then after you've done, you're finished with a clustering algorithm. Now each person, they're going to be assigned to one cluster. If it's a hard clustering, if it's a soft clustering, then they could be assigned to like some mixture of clusters, right? But that's neither here nor there. So now you can look at at sort of like these clusters that people are assigned to, and you could find the center of them. In other words, given this group of people who are all assigned to cluster A, what is the center point there? So what is like the person who would be most aligned with cluster A, like this hypothetical person who just perfectly lands in the middle of the cluster? And you say, okay, this is sort of an archetype. Like there's something unique about this group of people. You can also do this with like faces if you're trying to do face recognition, or even if you're trying to do object recognition. You can even do clustering on images and say like, okay, I have this huge bank of images, and they're falling into one of several categories. So I think clustering has been used for tons of different things. You can also then do machine learning on top of the clusters. What have you used clusters for in your work?
Yeah, I think like one of the things that came up recently is we noticed that which I guess like just thinking about your data is like we were doing some processing, and sometimes certain configurations of input were causing like the data to take a lot longer than other configurations. Sorry, speaking vague, but whatever. And so we were trying to kind of understand like, is there a difference or the features in one? And so this, what you kind of alluded to, it's exactly right, which is, hey, we have a whole bunch of measurements, like the size of the input data, like let's just say it was text, right? Like how many characters are there? How many lines are there? How many punctuation marks would there be, right? Things which we could kind of look and say, hey, is there something about this that's making the processing take longer or not? And once we sort of like, kind of started plotting it out and saying, oh, okay, hang on, let's look at what the clusters are of these like sort of easy inputs and hard inputs, and like oh, okay, well look, these hard inputs all have a lot of extra punctuation in them, and then realizing that the processing we were doing was going to cost a lot more when that happened, right? But we didn't kind of, it was vague enough that it's a bit difficult to sort of know that in advance and just look at your code and say, hey, actually I see here we do all this extra work in punctuation. It was a sort of like second order effect that was causing it. And so by doing this clustering and just looking at the results and saying, oh, look, these things are different than those things, allowed us to kind of say, hey, up front, let's check for that and handle them specially, or maybe decompose them further or do something special. And so that's what we used it for.
Yeah, that makes sense. I mean, one area where you see a lot of clustering is around log ingest and log reading. So imagine, you have a website. The website has a MySQL database. It's got, servers, backend servers. It's got the JavaScript on the client. And all these things are generating logs, right? Your server, your database is generating all these logs like, oh, I'm getting full up, or, oh, like the utilization is too high. Or I've actually, to be honest, have you ever looked at a database log, like a MySQL log?
No,
I've never
not
done
recently.
either. I just assume it works. It shows that we're terrible DBAs. But it's generating a ton of logs, and if your database like goes down, or all of a sudden it takes. I do have some. Actually, like there's a lot of popular websites that are only run by like 10 people. You know what I mean? Like, or I think Craigslist is famous for having just extremely small staff for such a popular website. But eventually, like you'll run into this where your site just doesn't load, and you're going to have to go step through all of these. So you look at the client, say, okay, the client's fine. You go to the server logs, and it just like says, it's just waiting on the database access, wait database results. Then you go to the database, it's like, yeah, utilization's 100%, and you have to end up doing something, right? Um, so you're getting all these logs. A lot of it is code that you haven't written, right? Because they're logs from programs that you're using. And you need some way to say, okay, can I separate the signal from the noise? Right? Like is there like is this log actually interesting? And actually a lot of these systems like Sentry and Bugsnag and these other systems use clustering. So what they'll do is they'll take every log line and they'll do what's called an embedding, which we can get to later. But they'll basically take every log line and turn it into a point in some space. So imagine some cube, but it's like a hypercube. It's like a 200 dimensional cube or something. Actually, we
I've
talked
got it
to
in my mind. Yeah, I've got the 200 dimensional cube. I'm
yeah.
picturing it in my mind.
That's how like Magnus Carlsen plays chess or whatever. But we talked to Ito Liberty about embeddings on that show. And so yeah, you have this big cube, and you've figured out a way to take these lines of log and put them in this cube, right? So if I have a log line that's printing every second, that's like, things are good. It's like 1901, things are good. 1902, things are good. That's going to look the same, right? It's always going to say things are good and then some kind of date, right? And so since it's so similar, and even the date, the number, the timestamp is also kind of similar, those will likely end up close together in this space, right? Once you've done this embedding. And so you can throw all these logs into that space and then do clustering. And chances are the things are good message will get its own cluster if there's so many of them. And then you could just throw them all away, right? You could also do things like say, okay, this line of log isn't even really near any of the clusters. So it must be something pretty unique, pretty special. So maybe this one I should, send an alert or something like that. And that's called outlier detection. And that's also, it's a really hard problem, but there's a bunch of great libraries. There's PyOD. There's a bunch of great libraries for outlier detection. And they're all it's all very related to clustering.
So what are some other examples of unsupervised learning?
Yeah, I think a lot of these like words like unsupervised learning, reinforcement learning, a lot of them have become kind of really nebulous, right? As all of these fields have kind of overflowed, right? But now there's the hot thing is sort of self-supervised learning. And the idea with that is it's still unsupervised in the sense that you don't have a human. Actually, we should probably talk about that. So supervised learning is typically where you have a human in the loop. So imagine if I'm playing chess and I train some model to mimic my moves. So if I move the pawn, then I tell some model, hey, when you see this board, I want you to move the same pawn to the same place. And so it's supervised. I'm the supervisor, right? And it is just trying to mimic this, right? Now, unsupervised would be a little different. Unsupervised would be where, for example, you might train an autoencoder. So you might say, here's a picture of a chessboard. I want this algorithm to put embed that picture. So find a function that takes this picture of this chessboard and puts it and creates a point for that picture somewhere in this space. And then I want another function that takes that point and creates the picture again, right? And so you're going from the picture to the point back to the original picture. And so when you do this and you train this model, it ends up having to represent the essence of that picture in that point. So for example, let's say all of my pictures have the same chessboard and it's on a black table, right? And it's the same camera setup. It's like a tripod, so it's very reliable, very stationary. It's all pictures of this black table with this chessboard on it. So it can just recover the black table without needing any extra information, right? So, because every single point that we draw in that cube, when you go back to draw the picture, you're going to need that black table. And so that's where like this really powerful compressive ability comes in. So you actually, the points now don't need to differentiate based on the table. They're all going to have the table in it. And so, if 2 points are close together, then that means that the two images they generate must be similar, even given the similarities that there are broadly. Like they must be even hyperlocal. They must be similar. Otherwise, those 2 points will get pulled apart. And so the way the autoencoder works is, you generate the chessboard. It's not going to look exactly right, so you have some error, and then you say, okay, this pixel is like too dark, or you drew a pawn here and you really shouldn't have. It's empty. And so given that the right answer, you just tell the model, hey, here's the right answer. Adjust yourself, and it will figure out how to use that volume, that embedding volume, in the best way or in a good way to be able to generate all of those pictures, not just one of them. Does that make sense?
Yeah, I think so. I mean, that was pretty deep. But here, I guess when we were talking about like clustering, you don't necessarily, like you mentioned there, like the right answer. There's no way to necessarily feed back. So you're like, you might as a human tune something or do something like the number of clusters, and there may be algorithms you do that, but there's really no necessarily right answer. When you're talking about, it's still unsupervised, but this sort of like autoencoding, you're kind of giving a problem, constricting the amount of information that can be shared between sort of like the left half and the right half, and then trying to say like, you need to simplify down to a representation and then reconstitute that representation back to the original and then look and compare the two. So you have a well-defined metric for saying like, hey, how well did you do at your task? And so you algorithmically are supervising it, but as a human, you're not sort of like at each interval, sort of like labeling something or giving a behavior to emulate.
Yeah, that's right. And the reason why all of this kind of comes together is, clustering. Imagine you're looking at a group of people, like you're in a helicopter and you're looking down at a stadium full of people or something, or you're looking at a football game or something, right? There's these little dots, like they're maybe the size of ants or something, running around on this football field. So, like when you cluster, you're going to be using sort of the geometry of the field, right? So, if somebody is twice as far away, then that really has a big impact on whether they're going to be in that cluster or not with these other group of people, right? Um, and so for all of clustering, you need to have a space that's pretty uniform. So, like for example, let's say you fed a bunch of features into some clustering, and one of your features is person's age in milliseconds, and the other feature is person's height in meters, right? Well, like one is enormous, right? Your age in milliseconds, it's some huge number. And so the clustering algorithm will totally ignore the other feature because your height in meters is, I don't know, from, I guess 0.5 to 3 or something. It's such a small range. Actually, I guess there's nobody 9 feet tall. But anyways, so I'm trying to figure out the tallest person in the world is what, 8 foot? Anyway, so your range is tiny. It's like a 3 units, right? But your age in milliseconds is enormous, and so the clustering algorithm will just cluster ages until not pay attention to the other one. And so if you're trying to cluster images or text or some of these things, you quickly run into this problem where the thing isn't geometric, and so the clustering can't really take into account different dimensions in a way that's fair. And so the nice thing about this autoencoding is, the way that the loss kind of propagates backwards from the correct chessboard to that latent space to the input chessboard, the way that those dots move and the way that the things kind of shake up ends up creating like really nice spaces where all the dimensions have relatively the same importance.
This is interesting. So yeah, so you're training both halves, but you may be taking, I guess you were calling it like the latent space in the middle, the encoded thing, and using it as input to other parts of your system, or sort of like clustering in that sort of more well-formed space so that you can say things about it, even if you never end up reconstitute. Like, there's really no reason for you to get back to the original chessboard. Like, you had it as input. Like, you could just use it. You didn't really need that part, but it helps you to get that middle part that you could then use to do clustering on.
Yeah, exactly. So now let's imagine, imagine we have a bunch of people who go to your website, or we could even stick with the football analogy. We have a bunch of football players, right? And we have a bunch of statistics about them. And these statistics are all over the place. Some of them are important, some of them aren't important. The units are all different. And so if we just feed these players into some clustering algorithm, then it's going to have a really hard time. Like maybe basketball. I know more about basketball. So basketball, the people score a lot of points, but their height, in feet, let's say, in decimal feet, is going to be relatively small. So someone might score 20, 30 points, but they're only like 7 feet tall. And so you have like different scales there as well, right? Or assists or rebounds, number of minutes played, and so all of these have different, and even slight differences in units can really matter. You could do some type of, let's say, contrastive learning, which is a self-supervised approach. So you might say, here's a list of players who I felt played very similarly. So I could come and say, okay, Shaquille O'Neal and Dikembe Mutombo, they're both centers, really tall, strong people who are strong enough that they can just push their way through and dunk the basketball, right? Those people are very similar. So I'm going to pull these two people together. So, whatever their features are, we're going to create sort of a point for these two people based on their features. And then we're going to say these 2 points need to be closer together. Then I'm going to take, Shaquille O'Neal and like Anthony Hardaway. And so Anthony Hardaway is like a 3-point shooter, like small person, like for basketball standpoint, small person who goes and shoots shots from far away. So these people clearly are far apart. You might even actually just use the positions, right? They, you might say, okay, all the centers should be close together. And then take two people who are from two different positions, they should be far apart. And so in this way, you're not, it's not supervised learning, because you're not saying, okay, Shaquille should be right here, or, Shaquille should make like this many points or something. You're basically saying, these people should be closer together. These pairs should be close together. These pairs should be far apart. And it's contrastive learning. It's self-supervised if you can automate all of that without a human in the loop. Basketball is a weird example because at some point a human did decide you should be a center, right? So maybe not the best example, but you could even imagine like doing contrastive learning on images. So you could say, here's a bunch of images that are on the same website. And because just by virtue of them being on the same website, they should be pulled together. And then here's two images from two different websites, they should be pushed apart. And so if you do this and you have a low learning rate, because that's going to be a weak signal, right? But if you do this and you have a ton of images and you've scraped a lot of the internet, you'll end up with an embedding that's really powerful. And so contrastive learning and auto encoding, where you feed in the same thing that you're trying to predict, are two ways of generating like really nice spaces that then you can do clustering and other things with.
This is awesome. So we were sort of giving examples and sort of saying the algorithmic approach, I guess, to doing this. What are some like applications of what people do with the? I mean, we talked about outlier detection for logs. I think that was a good one we were talking about. It's like classifying things. Like, what are some other examples of applications of this process?
Yeah, I mean, all of the language processing is now pretty much done in this way. So, for example, it used to be that if you wanted to train a model, let's say to translate French to English, you would have to pay people to, manually translate tons and tons of things, like literally millions of sentences. And then you would train, your model on these sentences, and you would have some translation that just goes from French to English, right? It's extremely expensive, right? So now what they do is, they will do what's called a word embedding. So basically, there's a whole bunch of different ways to do this. So one way would be a self-supervised approach where you say, given all the words up to this word. So, like what was it called? Like the brown. What is that one that's like you see
The
all the
quick
time?
brown fox jumps over the lazy dog.
Yeah, that's it. Okay. So you say like
I didn't know this. That the reason that's a sentence is because for handwriting is it's like the shortest sentence that uses all the letters of the alphabet, or a very short sentence which uses all the letters of the alphabet.
what?
So it was a penmanship test. I never knew that.
I
I
never
learned
knew
that like a
that.
week ago.
What? Shut the front door. Wait a
No,
minute.
and then I was like sitting there counting them all. Yeah, no, no, yep, they're all there.
Wow. Oh my gosh. My mind is totally blown. I feel like that. Have you seen that video where the guy pretends to do a magic trick and he takes the straw and he has his friend like put the straw behind the other guy's back and it blows his mind? Anyways,
Yeah,
that's
yes,
me
yes,
right
yes.
now. So wow, that's freaking awesome. Okay, so is what the quick brown fox? Or no, the
Yes.
quick. I thought the
The
dog
quick
was
brown
brown.
fox jumps over the lazy dog.
I thought the dog was brown. Anyways, so let's say the quick
Any
brown
ordering
fox.
probably works.
So this algorithm will learn, like you give it the quick brown, and then it has to produce fox, right? Now, if you look at that in isolation, that's like almost impossible. But you give it a ton of these sentences, and in every sentence, you say, okay, here's the first word, predict the second one. Okay, here's the first two words, predict the third one, predict the fourth one, right? And you give it, all of Wikipedia or something, right? And so, yeah, I mean, for some of these subjects and objects, it's going to be really difficult. Like the quick brown, it could be anything. But you're going to also see a lot of correlation. So you'll notice, like, whenever you see of, like maybe you see the afterwards, very common. And so you'll actually learn a lot of structure from doing that, from what they call a forward model, right? And the awesome thing is it's effectively free. This is another thing because of Moore's law and because computers have become so cheap and so efficient, it's really the people time that's the killer for a lot of these things. Like if you can eliminate the time that a human has to do something, you're in really good shape. And so, with these forward models, you just download Wikipedia. I mean, you could do this on your laptop right now and predict the next word. You don't have to pay any humans to rate any sentences or anything. So now you have this embedding, which says, given a part of a sentence, I have some point in some space based on what word's coming next. And so, sentence fragments where the next word is going to be fox will all kind of be close together, right? It turns out now, if you do that same translation problem, but you work with that embedded space instead of with whole sentences, you need, and it's been a while since I saw this, but I think it's like 1/1000th of the data or something like that. I mean, it's extraordinary. I mean, the difference is unbelievable. And so, what used to take millions and millions of sentences, now after like 10,000 sentences, you're done. And there's even models now where they've actually done this jointly with different languages. And so they embed like literally every language into the same space. And then all they have to do is train the second half of it, which does the translation part. So yeah, so all of natural language processing completely redone with self-supervised learning. Like it's massively changed that field. And I think even with image processing, you're starting to see, a lot of interesting things. The image equivalent of this is where you basically cut a piece of an image out and you say, reconstruct that missing piece of the image. It's like, remember the magic eraser, that Adobe Photoshop thing? That was like really popular like 10
Yeah, the
years ago.
content aware. Yeah, yeah, yeah. So
Yeah. Yeah. And so you could, and so you could actually, yeah, you could erase a person and it'll fill the fence in behind them, right? So imagine, you cut the person out, but your intent in this case isn't to literally cut them out of the picture. It's to see like how good your reconstruction can be, and if and you immediately know what the algorithm did right and didn't do right. So in this case, you actually want it to generate. So you wouldn't do something really difficult like cut out an entire person. You'd randomly cut out squares, and some of the time it would be impossible because you cut out a whole car or something. But most of the time, you'll cut off parts of things, and you'll be able to
Yeah, like if you
reconstruct.
cut out one person's eye, you just copy their other eye or whatever and flip it or
Yeah.
something. Yeah.
Exactly. And so same kind of thing. So you have this model that reconstructs things by putting them into this big cube, and then you can just do more and more things on that cube. So if you look at DALL-E from OpenAI, this is what they did. So they trained a model on Wikipedia to predict the next word of the sentence, like I just described, and then they trained another model on images, and then they created another thing which said, I have captions for images. So I have like a picture of the quick brown fox jumping over the lazy dog. And and then I have that caption. Those 2 points should be close together. And then I'm going to take captions that don't belong with their picture, mismatched caption picture pairs, and those points should be far apart. And I'm going to take those input embeddings and now train, another what's called a joint embedding that tries to unify or push apart those pairs. And that's how DALL-E works. So then, when you go to OpenAI and you say, astronaut eating ice cream on the moon, it's taking those 3 models, the language model. I guess it doesn't need the image model anymore, but it's taking the language model and, oh no, it does. It needs the language model, the image model, and this joint model. It's using all 3 of them to generate that picture of that astronaut on the moon.
And the question is the Artemis capsule floating around the moon in the background to tie this
We
back?
should just type Artemis into DALL-E and see if it's on the moon or not.
I think but they have exclusions for like a lot of proper names and nouns and stuff. So I don't know. I don't know how that works.
Ah, really? Yeah, I used it a little bit. I found it to be, really captivating. There's something powerful about that. I've always been a really big fan of DALL-E, but other than this visual interactive fiction, I haven't found a practical use for it.
Well, it feels good to do a duo episode. I know it's been a while, but going through the habit of the first few many episodes of you and I doing this together, it feels good to do it again. Do our tools of the show, book of the show, news, and then this discussion about machine learning was a really good time.
Yeah, definitely. I think these are all very accessible, approachable things. You can use SageMaker or other tools. You can train on all of Wikipedia without having to download it to your desktop if you don't want to. I think I saw, training that model I just talked about will run you like $30 or something, which, is the price of like going to the movies. So it's not nothing. But it's also like pretty amazing that for $30 you could train a model on the entire Wikipedia corpus, and it'll come out correct and everything. So it's a lot of fun, amazing times we're living in, and I guess as a like final thing, anything you build, you're going to need to collect some type of metric to understand the people who are using your product. And so this is a really good area for folks to brush up on. All right, and with that note, yeah, it's really awesome doing a dual episode. Looking forward to seeing this one come out. Looking forward to seeing if we're right or not about our prediction, and really looking forward to your emails. We've been getting a ton of really great emails, so appreciate everybody out there. We do read them, even if Patrick has them marked as unread. He has looked at the subject. No, I think both of us literally read every email that we get on Programming Throwdown. So we really appreciate your support and supporting us on Patreon and Audible. So thanks so much. Definitely subscribe if you're not subscribed to the show using whatever podcast catcher. We should be on all of them at this point. If we're not, let us know. And we will catch y'all in 2 weeks.
Music by Eric Barndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.